Okay, this video is on the volume of a tetrahedron and the vector triple product. So both of these things are really cool. A tetrahedron is just a pyramid that has a triangle on the base. Whoop, don't knock my markers down, sunshine. So the pyramid is the base, a triangle is the base, and it comes to a point. So the volume is the cross product of vectors v1 and v2 dotted into the vector v3. Now, the first time I saw this formula, I was like, wow, that's so cool. Why is it true? And I want to explain to you why it's sort of just true on its face. It's very, very simple. So we know that anything that comes to a point has a volume of 1/3 the area, the base area times its height. For any object, you could have any kind of base like this. If this is, as long as it comes to a point like this, whatever, this is going to be the formula. So we just need to evaluate the area and the height. So the area, when we take the cross product of these vectors v1 and v2 like this, it gives us a vector that's perpendicular to them. And this cross product has the area is 1/2 of the magnitude of the cross product of vectors v1 and v2. The full cross product gives you the area of the parallelogram, and half the cross product gives you the area of the triangle. And then the height, this cross product is perpendicular like this. And then if we normalize this cross product, the height is v1 cross v2 divided by the magnitude of v1 cross v2. This is just the unit normal that's perpendicular to the plane defined by v1 and v2. And then if we dot this into v3, the projection operator here, dot is acting like a projection operator. So we're saying of this vector v3, how much of it is along this normal vector, which is the height. And then, so there's our formula right there. We plug in the pieces. The area is 1/2 of this, and the height is this thing. So, well, here, let's do it. The area is 1/2 v1 cross v2. The magnitude, I'm running out of space. Well, it's much simpler. These cross out, and the 1/3 times 1/2 gives us 1/6, and we're left with this formula with a 1/6 in front of it. So there's the vector triple product for you, and that's how you calculate the volume of a tetrahedron. Why would anybody care? Because it's super cool. Most of the time we just have binary operators like dot product or cross product or multiplication or addition. This is a ternary operator. We have 3 vectors that are involved. And thank you very much.